Let's examine our amazing eye. When we look at distant objects, objects that are very far away, our eye is in the relaxed position. That means the lens of the eye is relaxed. So for us to see that object, an image of that object has to be formed on the retina. The size of the average size of a human eye is about 25 millimeters. One question might be is to determine the focal length of the eye when looking at an object far away. Okay, to do that, we have to decide what the object distance is. For an object that's very far away, we can say that the object distance is infinity. Now, for the image to be formed on our retina, the distance from our lens to the retina is what we call the image distance. So in this case, that's going to be approximately the size of the eye, 25 millimeters. So to find the focal length, we use the thin lens equation. 1 over f is equal 1 over do plus 1 over di. So 1 over f is equal 1 over infinity plus 1 over 25 millimeters. 1 over infinity is 0. So we end up having our focal length just equal to di, or 25 millimeters. So under the relaxed position, our eye has a focal length of about 25 millimeters. Now, what about when we look at a close-by objects? Objects that are 25 centimeters away. 25 centimeters, that's 250 millimeters. We say that the eye is tense then, the lens is kind of compressed. We still would like to have an image on the retina. Now, to find the focal length, we are going to use the same approach, which means we are going to figure out our do. Our do is going to be the distance away between lens and object. So in this case, it's going to be 250 millimeters. Our di is the same, 25 millimeters. Using the lens equation again, 1 over f is equal to 1 over do plus 1 over di. So in this case, it's going to be 1 over 250 millimeters plus 1 over 25 millimeters. Multiply both sides by 10 here to have the same denominator. So we have f is 250 over 11 millimeters. 250 over 11, that is 22.7 millimeters. You notice that the focal length does not change quite a bit. The bottom line is the eye lens changes shape. It's going to be relaxed or tense. By changing shape, it changes the focal length. In changing the focal length, it allows us to be able to see an object at any distance away from the eye and form an image of that object on the retina. That is 25 millimeters in the back of the eye. Now, note that there are limits on how much the lens can change shape. Can change shape only so much. Because of that, there are points beyond which that we are not going to be able to see clearly. For example, points that are closer to us than what we call near point. Anything that's closer than the near point, we cannot see it clearly. The near point for people with normal vision is about 25 centimeters. For the people we call far-sighted, it's going to be larger than 25 centimeters. So, for people under normal vision, objects that are closer than 25 centimeters, or our near point, cannot have a clear image formed on the retina, so we don't see those clearly. The far point is the furthest point at which, when we place an object, we can still see it clearly. For people with normal vision, the far point is infinity. You can see an object clearly no matter how far it is. You might not be able to see much of it. It might be so tiny in your retina that you don't see much. But if you are going to see it, it's going to be sharp and in focus. People who are nearsighted are not going to be able to see objects that far, so their far point is going to be a smaller distance than infinity.